Sometimes we have to create objects that have a lot of properties or settings that we need to set, or perhaps they actually have sub-objects as well that we have to deal with. So the process of creating these objects is really long. The builder pattern is a pattern that we can use to help with that problem. So we need to construct multiple type classes, meaning that they have complicated construction methods. They may set a lot of properties. They may have sub-objects. They may have arrays that we have to go through and initialize multiple instances. So the object has a number of different things that we need to do to construct it. For instance, if we were working with a database, we may need to build up our connection string, and then build up a command type and a command object, and then set timeout properties. And perhaps if we're going into a data layer, we may need to go a little bit further, and the construction process is that much more complicated. For measurement data sources, we might have a serial port. And if you've ever set up a serial port, it has a number of different properties. Port number, baud rate, parity, all that kind of thing that we have to handle to set up the serial port. We might also have an Ethernet connection, and it has an IP address and a port and a timeout and other things that we need in order to set up our data source. If we're talking about perhaps a business object, like maybe an order will have a number of properties, a customer property, order date property, and then it might also have order details, which have a number of different items, and each one of those items would have to be constructed. So that could be a very lengthy construction process. What we don't want is we don't want all of these lengthy constructors sprinkled out throughout our application. We want in our application to simply be able to call a single method that builds these things up out of our application code, so that it's clear in our application code that we're building a database or a measurement data source or a business object. But we don't want the application code to have 20 lines of methods that actually do that building. We would like that to just be as very simple and clean as possible, so it doesn't clog up our application code and make it that much more difficult to read. So the builder pattern helps us in this. It'll create a builder interface or an abstract class, and that will be a generalized object construction interface. In that interface, we'll provide methods for each object's construction step. So if we're working with a database, it'll provide methods to create the connection string, then the connection object, and then the command object, and whatever else we need further from there to create our database object. We then create builder classes that implement the builder interface for each object type. So if we're building up SQL Server database objects, we would have a corresponding SQL Server builder class that inherits from our more generalized abstract builder class. And it would implement the methods in each step that was required to build up our SQL Server database. Once we have our builder class that presents those methods, we have a director class. And the director class will use the builder class to create the object. And once it uses the builder class, it'll present the object to the application code. So it'll hide all of those messy creation details from the rest of the application. So if we're going to construct a database class, we might have SQL Server and OLEDDB options. And we might have methods for creating connection and command objects. And we might want to also set command parameters. This is actually a relatively simple example of using a builder pattern. So for our classes, we would have a database abstract factory class. And if you haven't looked at the abstract factory pattern, you might want to take a look at that. We're going to be using it in the code example. So in that abstract factory, we would have an abstract database class, and then SQL Server database classes, and then an OLEDDB database class. And both SQL Server and OLEDDB would inherit from our abstract database class. So that's a quick overview of our factory classes, and those are the classes that we actually are going to want to build. To build them, we're going to use an iDatabase Builder interface. And on that interface, we're going to have a build connection method, a build command method, and a set settings method. We'll also have a database property, and that's the database object that we want to build. So we'll have instance classes of type SQL Server Database Builder and OLEDDB Database Builder. And those will implement iDatabase Builder. Now, if you're not familiar with interfaces, you probably ought to study those because we'll use them a lot when we're using patterns. But the important thing of an interface is it presents a contract. So when we pass an interface to the application, it's going to know that it can call the methods that are called out on the interface and the properties that are called out on the interface as well. and it might handle the events. So an interface can declare the properties, methods, and events of an object. However, an interface is not an object in itself. It's basically just a contract. So there is no implementation in the actual interface. So iDatabase Builder doesn't have any implementation for build connection or build command or the database property. It's just saying, this is the method signature, this is the property type, and here are the names of the methods and the properties. Any class that implements the interface has to implement those methods and those properties that are declared in the interface. So that's the contract part. Our SQL Server Database Builder and our OLEDDB Database Builder classes will implement iDatabase Builder, which means that they must implement build connection, build command, set settings, and the database property. The director class will have a method called build. It doesn't have to be called build, but it should be named something clear and obvious to the application code that an object is being built or created, something like that. So in our case, we're just going to call the method build. It'll take an iDatabase Builder parameter. So it'll use its parameter, which implements the iDatabase Builder interface, to call the methods that actually construct the object. Then after the build method is done, the builder will have a database property, which will return our fully constructed database instance. So here are our class diagrams. On the left, we have our director class, and it simply has a build method. And as we just said, that build method will have a parameter of type iDatabase Builder. And that's right below there. An iDatabase Builder has the three methods, build command, build connection, and set settings, and the property database, which is ultimately going to be what we return in the whole point of the builder. Then next to the builder and the director, we have the abstract factory classes. So we have our database abstract class and the OLEDDB database and SQL Server database that inherit from them. And then further to the right, we have the classes that implement the iDatabase Builder. So we have a SQL Server database builder, and it has an internal field _database, and that's what it's going to use as we call the build methods. And then it has a property database, which of course is required by the interface, and then the three methods that are required by the interface as well: build command, build connection, and set settings. It also has a constructor. In the constructor, it'll build up a new database object, and then as each method is called, it'll build up that database object so that when the final set settings method is called, the database will be fully rounded out and it will be able to return it. The OLEDDB database builder does the same thing, except it's going to create an OLEDDB database instead of a SQL Server database. So that's the idea of the builder pattern. And the whole point of the builder pattern is to take a complex construction and to hide all of those implementation details from the application code.